First of all, good morning. Thank you very much for joining today's Fix China Working Group meeting. To kickstart, I would like to remind all of you that this event is being recorded and this meeting is conducted under the standardization IP policy of Fix. Today's meeting will be conducted mainly in Putonghua, but the presentation sessions will be conducted in English. 各位早上好。我先欢迎大家，非常感谢你们参加今天 Fix 工作组的会议。首先，我想提醒大家，这个会议正在被录影，而这个会议会根据 Fix 的标准化知识产权政策进行的。今天的会议主要是以普通话进行，但演讲的环节会以英语进行。今天的会议呢，会有 Fix 中国工作组的联合主席吴小平先生和 Dylan Manevin 先生主持。我先请 Dylan 讲几句话。Dylan, over to you.
Thanks, Sammy. I think I just wanted to briefly say thanks to everyone for attending this event from the Fix China Working Group. We hope it's an educational hour discussion and learning about the SPE in terms of Fix. As well, I guess I would just encourage everyone to make this as engaging as possible so we can try to make this as educational and informative as we can.
Okay, thank you. 现在有请吴小平先生正式主持今天的会议。小平，有请。
好，那个大家好啊，大家早上好。那我先介绍一下今天这个讲座的一个议程。那么今天讲座主要是分为3个部分。第一部分那个有门德尔森先生先介绍一下简单二进制编码，大家可以参考这个前期发的这个 PPT， 有中文的对照。那么第二部分是我们会进入一个问答环节，欢迎大家踊跃的用中文提问。也可以用中文提问。那么用中文提问的话，我们会有翻译。这是第2部分。第3部分呢，我们也希望大家对于未来类似的这个培训议题有什么好的建议，或者有什么感兴趣的地方，提出一些见解和看法。那么今天的议程主要是这样子。Sammy。
谢谢。我提醒大家可以尽量的提问，我们在最后的阶段，我们在简报以后会尽量回答的。现在我有请的在美国的 Fix 技术架构师Mr. Don Mendelson 为我们介绍简单的二进制编码 Simple Binary Encoding。Over to you, Don. The time is yours, Don.
Okay, sorry, I was having trouble unmuting there. Thank you for having me, and I'd like to present a session on simple binary encoding. And it's a rather lengthy presentation. We've given several times for different purposes. So for today's session, I plan to skip over some sections that may be of less interest. However, if you have an opinion about what you'd like to cover more, please let me know. Why SPE? Why did we create SPE to begin with? So traditionally, Fix has been message encoding has been what's called tag value. So I'm sure many of you are familiar with this. It sends messages over the wire in printable characters and in the form of a tag number, but it's actually not even a number. It's the character representation of a number, an equal sign, and some value. So originally it was specified as an ASCII encoding, ASCII being a traditional American character set that was a 7-bit character set. That has since been expanded in tag value to allow for Unicode characters, but still it's a character representation of the data. So whether it's numeric or a date time, what happens is you have some machine that's producing market data or orders or post-trade information, and it's converting numbers and date times and these kinds of things into a sort of printable representation to send on the wire. And this was really a wasteful operation because in most cases we're sending fix. It's a machine-to-machine communication. So why does it need to be humanly readable? So translation back and forth between the printable format and the machine processable data is really wasted effort. So every field has two delimiters, a tag delimiter, which is an equal sign, and a value delimiter, which is a control character, which is SOH character. Another issue with tag.
Sorry,
yeah, go ahead.
Don. Are you sharing the slide? I think we're not able to see the slide here. Yeah.
Okay, let me try that again. Thought I was sharing. Share. Okay, sorry about that.
Yep, we see it now.
Okay. So I apologize. Another aspect of the specification that it's entangled with the session layer, which is not fit for purpose for high performance trading. Very large variable message size, verbose headers. There's message integrity features, including body size and checksum, which are really unnecessary in today's computing, which are much more reliable than when FIX was created over 25 years ago. Now, a performance problem with tag value encoding is that it's highly variable, which leads to very non-deterministic performance. So the order of fields in a message is not deterministic. They can be in somewhat random order. So if you're trying to decode the message, you don't know necessarily exactly where the field is going to be. You may have to process all the fields prior to the one that you're interested in to get to it. So in other words, you don't have direct access to key fields such as price, quantity, symbol, and things of that nature. FIX was designed for a very high degree of optionality. So if you look at the definition of, say, the execution report message, it has something like 200 possible fields, or maybe even more than that. But if you look at what are the required fields, it's really only a handful. So it's more defined as to be possibly not present than are required to be present, and that causes this high degree of variability, the design of the messages. It's partly self-describing, but not entirely self-describing. So people who work with FIX a lot know that tag 44 is the price field and things of that nature. However, there's aspects of the message that are not fully self-describing, so it's not context-free. And the reason that that's important is it requires a data dictionary in order to decode the message. Repeating groups can be heterogeneous. So in a market data snapshot, for example, you could have a bid entry, you could have an offer entry, you could have a statistical entry. They don't all have to be the same type of entry within a repeating group. Again, very highly variable. So for what we'd like to do for high frequency trading is optimize for low latency for the encoding and decoding of a message, but just as importantly, we want to very deterministic performance. We don't want this high variability. So you can't just look at averages. You have to look at, what's the long tail of, the latency time that prevents processing from working smoothly. Secondary importance is we want a concise message size, but we don't necessarily want to put a lot of operations into compression. And the reason I bring that up is some of you may be familiar with an earlier fixed standard called Spe and Fast, which was used for market data. It was designed for market data. And that was created at a time when the cost of transmission of high volume data was very expensive. So they put a lot of work into compressing the messages. And so you get very, very small message size. However, there's a trade-off there. You get a lot of CPU cycles going into doing compression and decompression. So we made a decision for SPE not to do that. We're not doing extra compression, but we're just using very reasonable message size to begin with. A requirement for fixed SPE is that it should support all the fixed semantics that people are familiar with. So if you know the semantics of fields like order quantity, Hume quantity, leaves quantity, and so forth, we should be able to represent all of those things and represent all of the fixed messages. There's also a requirement that we support fixed messages from various versions of the past, 2, 4.4, and 5.0 with extension packs. And we need to be able to represent all of the traditional fixed data types. So there are things like integer and quantity and amount and UTC timestamp and things of that nature. I'll talk a little more in detail about those things. The semantics must be unambiguous. So we can't have confusion, as we did in tag value, between floating point numbers and exact decimal point numbers. They really were encoded the same way in tag value. Those should be totally unambiguous. And remember, we're engineering this for machine-to-machine dialogues, not for human readability. So that is not considered a requirement. However, that can be that need can be met by translators that convert the machine readable code into human readable text. So let me talk a little bit about fixed standards. We have a specific procedure for developing fixed technical standards. I'm not going to go into detail of that. There are a few slides in the deck about that, but I'm going to skip over that for today. But I will suffice it to say that we have a procedure for standards development and publishing those standards. Now, that I want to distinguish between a standard and implementation. Firms and vendors are free to implement the standards in ways that are suitable for them, and they could add features to it, add conveniences and so forth, so long as they are interoperable with other implementations. So let's talk a little bit about network standards. You may be familiar with the OSI model, where it describes a layers of network standards. So the very bottom, we have the physical network signaling and so forth, and there's a data link layer, network layer going from the bottom up. I'll say for today's discussion, we have no interest in those bottom three layers. We're talking about what comes about that in terms of software. And of course, the application layer is the business semantics. Identity synchronization are features of that layer. Presentation layer, you can also call message encoding, is the message syntax. It also could mean encryption of messages. And below that, we have the session layer, which is how the peers talk to each other. What is the dialogue? And then responsibilities include checkpointing and recovery. And then below that, we have transports, and you may be familiar with things like TCP and UDP and so forth that are responsible for connection, multiplexing of event flows, flow control, things of that nature. So right now, I'm going to drop out of this presentation and show you kind of the big picture of fixed standards. So this is the layers of that I just showed you, but how the fixed standards fit into that. So at the top layer, we have the application layer, and we have fixed 4.2, fixed 4.4, 4.4 and 5.0, and now we have something called fixed latest. And fixed latest was where all new features come into the fixed standard, and those are the things that that we do maintain. Below that, we have message encodings, and so here's our tag value encoding. And that is what we could call fixed classic, the original fix protocol. And SPE is a sibling to that. It's a message encoding, and it's independent of other layers. And I'll talk a little bit more about this independence in a minute, but you'll see below that we also have standards for session protocol. And we have a newer one called fix P, which perhaps we could do a presentation on another day. So I want to come back to the presentation. And now here's what we were just talking about in terms of the original fixed standard, of what I call fixed classic. So from fixed 2.7 to 4.4 and 5.0 really, well, I'll say 4.4 for the moment. We have application layer, presentation layer, and session layer all combined into one standard, one protocol. Now theoretically, fix is transport independent, although fixed classic was almost always done over TCP. But the term I've used here, there's actually was a white paper that someone wrote called the big ball of mud design pattern. So if you're familiar with design patterns, the big ball of mud is everything basically lumped together. Another name for it is, you have like a God class that knows everything about everything. This is really not a good way to do protocols. So when we came along to fix 5, we got a little bit wiser, and whoopsie, let's see, I'm sorry, I got off. Let me come back to that. I think I had a slide missing. There was, we got a little bit wiser, and we split off the lower layers so that the session layer could be more independent from the upper layers. So, but we still had like bundling of the application level logic, presentation layer, and some session layer logic mixed in, because the session layer defines the standard header, standard trailer of fix, which are defined on every application message. So there's not a total separation. So I'm going to skip over this part about standards and come to the design of SPE and how that fits into this. So the main point I want to get across up to now is that SPE is, in contrast to Fix Classic, the older versions, is just at the presentation layer and is not concerned with what becomes with the layers that are above or below it. So one of the key design principles of SPE was binary field encoding. Again, this is machine-to-machine communication. So we created a fixed type system. You have a type system such as you have in programming languages, must represent all the fixed field types without unnecessary conversions. But we want to base this on the primitive data types that computers understand. So we have the primitive integers, our native types on practically all platforms. And we could represent decimal numbers for prices and so forth with either flexible or fixed precision in this type system, but also things like timestamps, times and dates. And we send them as numeric units rather than as very verbose strings that we sent in the tag value encoding. And we also have ways to encode enumerations, and we have a multiple choice representation sent as a bit set on the wire. So on the left side of this table, we have the traditional fixed data types. So we have things like int, or short for integer, length, sequence number, etc., a day of month, quantity, float, price, amount, etc. And then what we did when we designed SPE was we came up with a binary representation for every one of these. And we really drilled down. So in tag value, integer is just an integer. It's not really specified any more closely than that. It's very vague as what that means. But in SPE, we have signed, unsigned integers and of different sizes. So we have an 8-bit, 16-bit, 32-bit integers, etc. And then we have ways to encode decimal numbers, floating point. We have character representations. So we have char, which short for character, which is a single character. We have string. Now in tag value, it was just always a variable length string. So it just went up to some delimiter. But SPE, we more closely defined it. We could have fixed length character arrays, or we could have variable length encodings of strings as well. And we have data, which is by definition usually variable length. But we also have in fixed things like country codes, currency codes, exchange language codes, etc. We have a way to encode enumerations. I'm going to skip over multiple char value because they're not exactly representative, but we do have something called a bit set, where you could turn on, you could think of it as an array of Boolean values, on-off switches that you could send on the wire. Boolean type, we have a month, year representation in fix, and we have various time and date field types. So let me show you some specific examples of how SPE looks on the wire. So let's take the binary encoding of UTC timestamp, and I have time and date. So the binary encoding, which is a representation of a number of nanoseconds since the Unix epoch, which was January 1st, 1970. In SPE, that takes 8 bytes, and I'm showing a hexadecimal representation of that. By contrast, in tag value encoding, it's sent as a printable string, and here it is shown with millisecond precision, and taking 21 bytes on the wire. So it's not only is it more compressed in SPE, but we actually are doing it with more precision. So what happens when you have multiple fields in a message? So I'm showing an example here, a fragment of a message on the top. In SPE, there's no delimiters. There's no tags on the wire. That's only represented in metadata, which I'll show you later. It's just data only on the wire, and it's just one field after another without any delimiter, because the metadata tells the size of the messages, so you don't need to send the delimiter. So the first field is price, and it's taking 4 bytes, and then we have an order quantity taking another 4 bytes, and then we have a symbol, and it's a total of 12 bytes to represent those 3 fields. So again, looking at the tag value encoding below that, we have the same 3 fields in tag value encoding. So we have 44, which is the tag for price. So it requires this data dictionary to know what it means. Equal sign is a delimiter, and then the number, and then it's shown as a box on the slide, but that's actually a control character that takes up that byte position that says, okay, and now I'm ready for the next field. And then we have the order quantity field, the symbol field, and so on. So another principle of design of SPE is that we want to have very simple data structures. And we want to also maximize direct access to data. And so we want to, wherever possible, have field in a fixed position in the message. And why is that an advantage? You may have some part of an application that is, let's say, either filtering messages or routing messages. And let's say you're routing messages by a symbol, by the trading symbol. It'd be very efficient if you knew exactly where symbol is in the message, and then you could just read that field directly without having to interpret everything that came before it and after it. So that's the advantage of direct access. So we favor fixed position fields. They always have the same offset from the start of the message, and we know for a part of a message how much space is allocated for it. And one way we do this is by the way we treat null fields, for optional fields, to represent that no value is encoded or it's not present, is we put a special value into its place, but the null value has the same space as the normal value. So that keeps it into the fixed position. And so we have a preference also for fixed length fields, and that kind of goes together, fixed position and fixed length. So character data can also have fixed length. So let's say, again, you have the symbol field. In US equities, the symbol is typically limited to 6 characters. So you could define this as a 6-character array as opposed to a variable length string. And the symbol is always in the same place and it takes up the same space in the message. The specification for SPE defines what the null value is for each encoding type. So this table shows what it is for the various integer types. So we have int 8 is a signed integer of 8 bits. We also have unsigned 8-bit, and then signed, unsigned of 16-bit, 32-bit, 64-bit. And so you would, when you design a message, you would pick the correct integer type based on the range of values that you need to encode in that particular field. And then, so let's say that, let's just look at the unsigned 8 as an example. The minimum value is 0. The maximum normal value is 254. And we have the special value, the null value is 255. And so we're showing it in decimal format here, but if you would see it in binary or hexadecimal, it's more apparent that the null value is just the extreme range of the value as it's encoded. So we also support direct access or nearly direct access for repeating groups. So one change we made versus the tag value encoding is a repeating group is constrained to be homogeneous entries. So they all have the same field layout within a repeating group. And this, again, is a deterministic data structure. So we have just a very small header in front of the repeating group that represents what you usually called the num in group, the counter of how many entries you have in the repeating group. But it also has in SPE encoding the length for each entry of the repeating group. So this supports direct access because you know from that small little header in front of the repeating group the count of entries and how big each entry is. And so again, to go from the first entry to the second entry and so forth is very deterministic in how much space is allocated for each. Now you can have repeating groups, nested repeating groups, but they follow the same format in a nested form. Seems like we had some duplication. Oh, I'm sorry, I hit the wrong button there. Okay, so when we decode the message, we depend upon an out-of-band message schema that tells what the message layouts are. And I'll go into a bit of detail on the message schema, but it's an XML schema that describes SPE message layouts. And since we could tell from the metadata how big each field is and how big each message block is, that eliminates the need for delimiters within the message. So it's just field 1, field 2, field 3 on the wire without any very much extra bookkeeping. We have a feature where if you have a constant for a certain value in a message, it's defined just in the metadata and you don't even need to send it on the wire. But we have things in metadata like decimal price or time precision, again, specified out of band. So the message schema describes each field in terms of its tag, its data type, and its size. And again, since the layout is in metadata, we've reduced the size of the message by eliminating those delimiters. And we could also specify in the metadata some other aspects of the fields, such as minimum, maximum values, enumerated values, and so forth. So I'm going to go into a bit of detail on message schema. Again, this is an XML schema that defines your SPE messages. I'm, however, going to skip over some of the examples that are in the slide deck, but this slide deck will be distributed after the meeting, so you could read those over later. And of course, I will accept any questions that you may wish to send me after this presentation. So I first wanted to define some terms. Message schema is a collection of message definitions and their associated encoding types. A message template is the layout of a single message. A schema may contain any number of message templates. And an encoding type is a fragment of wire format associated with a generic data type. So in the XML schema, we have a root element, which is called message schema, and it contains types, tag, and a message tag. So a type is the wire format information, and a message is the layout with fields that use those encoding types. So a message is a collection of fields, groups, which are repeating groups, and data, which is variable length data. So by field, I meant fixed length fields. And the message is structured in exactly that order. So fixed length fields come first in the message, and that optimizes the direct access. And then we have repeating groups, and you could have any number of repeating groups. And then following all the repeating groups, you have variable length data, which may be variable length strings or variable length opaque data that is 9-character based. I did that again. So the types, the encoding types, are of these 4 types. There's a simple type, which is a scalar or array of scalar. And so those are things like int or char types. And then we have composite types. If you're familiar with, say, C language, this is like a struct in C language. It's a composed of 2 or more simple types. And then an enum is an enumeration of valid values. Now, lately in FIX, we're calling that a code set. And so finite list of valid values. And then a set in SPE is a bit set, which is an array of Boolean values, on-off switches. So I'm going to skip over some detail here. But in the schema, for each field, it has a name, an ID, which is its traditional fixed tag, a data type, which is just called type in the XML schema. We can optionally give an offset, and one thing this allows you to do is create special alignments of bytes on the wire to optimize performance. And we could give a presence as optional, required, or constant. And we could also relate it to a semantic type, which is the traditional fixed data type, which while type is the encoding type, the wire format. And you can give an optional human readable description. And since version, I'll explain later, we have a scheme for extending messages. After you define them, you could add on to them later. So what I'm going to do is I'm going to skip these XML examples because they're quite involved. But just to show you an example of a fixed message that's encoded using SPE, what we have on the left side is the binary, or actually it's hexadecimal representation of each field, and on the right is the metadata and a readable representation of it. So the first field there, the metadata tells us that it's tag 60 transact time, representing this date time, but it's just a hexadecimal representation of what's on the wire. Again, to emphasize, tag 60 and transact time are not on the wire, they're only in metadata. And you can see all of the different values. So we have a trade-off in our design. Tag value encoding had a high degree of optionality, easy way to add fields to messages. SPE, on the other hand, helps us achieve determinism. But messages must change over time, let's say to meet new regulatory or business needs. So how can we get both the determinism but growth of a message over time? So for that purpose, we have something called the extension mechanism in SPE. The motivation is it's not always practical to update all message publishers, consumers simultaneously, especially when the consumers of your messages are customers and they're not under your direct control. And sometimes it's very difficult to get people who are not in your own organization to do things on a schedule. So there's a need for compatibility of versions of a message schema. So that's what the extension mechanism is for. It allows us to add fields to a message, a later version of a message, at the end of a block. So it could either be within the root of a message or within a repeating group. And there's some other details about extension here. We have to accept some constraints for this to work. One is that the order of fields is not changed. We're only appending new fields to the end of a block. You can't change things like the data type of an existing field because if a decoder is behind a version, it wouldn't know what to do with that sort of change since the data is not self-describing. And you can't fully change the structure of a message. So if you do have radical changes to a message, we recommend that you just publish a new template. But this allows a existing message template to grow in a very structured way. So I think I'm going to skip over some of the detail of versioning for now, but I will just say that a message schema is versioned atomically. The whole thing has one version. So when you publish it, you're publishing a new version of the whole message schema, not individual. Templates are not versioned individually. So we created SPE version 1.0, and that went through the whole cycle of protocol development and has been published as a fixed standard. Some people expressed a desire to add whole repeating groups and variable length elements to an existing message. So this was an expansion of the message schema extension mechanism that was not in version 1.0. So what you will see if you look at the SPE standard is release candidates for version 2.0 that allow for that, but that has not gone through the whole cycle of development. And I'm gonna skip over some of this in the interest of time, but just a pictorial representation of the top here is version 0 of a message that has a certain block size. Version 1 has added an extension onto that. And even for repeating groups. Now this is some material for developers in how SPE can achieve very high performance by managing your message, your memory properly. I think I'm going to not dive into detail on this, but you can read this later on. I want to leave enough time for discussion and messages at the end of this. So I did say that we released version 1.0 of SPE, and we have release candidates of version 2. One thing that I want to add here that is not in the slide deck, because it's more recent, is we plan to make a submission of SPE version 1.0 as an ISO standard as well. So it will be a joint standard of FIX and ISO. So we've actually already prepared the material for that, and we're just in the early stages of submission. So I'm sure that will be of interest. So again, kind of wrapping up here, I just want to leave some time for questions. Some of the great things about SPE is that one thing is that messages are context-free, unlike the original FIX protocol. In FIX protocol, originally, you had to update the message with session information like sequence numbers, sending time, and those things. That is totally out of scope for SPE. They're totally self-contained and context-free. Another interesting feature of SPE, since it allows you to define things down to the byte and even control byte alignment and so forth, is you could mimic other encodings, such as, for example, a NASDAQ ouch protocol, and use its mechanisms to look just like existing standards. So you may find that of interest. There are at least 3 open source implementations of SPE. The one that's the leader, I will say, is an organization called Real Logic. And you could find that implementation in GitHub. And there are others out there, and they're in various programming languages. So some of the open issues, things that if we go to later versions of SPE, I think could use some improvement. One is better message composition from reusable parts. We have that in other aspects of FIX. So in like FIX Orchestra, we can compose a message from components, which are reusable blocks, things like instrument block, and things of that nature. We don't really have that in the SPE message schema, although that has been proposed. It's not part of the standard. There's some confusion about what should be a composite type as a wire format versus what should be in a field in a message. Some of the existing fixed data types are, if you read their description, they're somewhat tied to tag value encoding. They tell you, this is what it looks like on the wire in printable characters. That's something we need to work on within the fixed organization to improve that, to make the fixed data types more generic and not dependent on any specific encoding. And again, if you look at fixed message descriptions, some fields are described as floats, but there's kind of an ambiguity there. Do they really represent an exact decimal type, as prices usually are, or do they represent truly a binary, floating point number, such as a ratio or a rate? And I think we have some confusion of data types within fix. So this is not a problem related to SPE specifically, but does have an impact on it. Fix also lacks a duration data type, which I've noted a number of times, a duration in time. So some things to be aware of, that SPE messages are not self-framing, but one way around that is we have another standard called simple open framing header. It's just a very tiny header that has an enumeration for what the encoding is that follows. It even allows you to mix encodings on the wire. So what follows is SPE, and it has a message length. So that allows some utilities that need to handle messages, let's say to persist them, for example, don't need to crack the message to know how big the message is in order to just to persist it without understanding its contents. Another issue is editing message schemas. It's XML file, and it's pretty much been done with XML editors. It'd be nice if there were utility to do that, or a domain-specific language, a DSL, such as some other encodings have, like Google Protocol buffers as a .proto file, for example, with a simple textual representation. We do have other ways of representing messages, and I just make a quick plug for Fixed Orchestra, which is becoming prominent. It also would be nice to have a tool to render messages into humanly readable format off of wire, like packet captures. I'm suggesting if somebody would volunteer to create what they call a dissector for Wireshark utility to do protocol analysis using SPE would be nice. Okay, that's the end of my presentation. So I'd like to just open it up for anybody who would like to ask questions or make any statement you'd like to make.
Okay, thank you, Don. And yes, as you said, I think we will start the Q&A sessions, which I will get Carl Lu to help as well. 我们在那个会议之前收集了一些问题，也看到在 Q&A 里面有一些问题已经提出了，我有请那个 Carl 帮我看一下这个问题，然后向那个 Don 提问，Carl。
Yeah, no problem，没问题。
我看到里面有一条提问的，你可以帮忙看一下吗？
Sorry, Sammy, is there like a button I can click so I can see all the questions?
Yes, it's on a chat there. So you can take a look at one of the questions there.
Chat. Okay. Sorry, I don't know where to go to the chat.
Maybe it's at the bottom. Maybe I'll try to help to ask the first question. 有一个问題是想問一下這個 SPE 和 Fast 的區別是什麼？Don, the question is, what's the difference between SPE and Fast?
Yes.
Is there anything that you can share?
Yes. Fixed Fast was around before SPE. It was designed specifically to optimize market data. And a feature of Fast was, I kind of alluded to this earlier, but at the time it was designed, we had very high volumes and growing volumes of market data, and it was getting very expensive just for the capacity to transmit that much information. So a lot of effort in Fast was put into doing data compression. And so it's done at a field level. Just to give you one example, there's something like a delta. Instead of sending the whole price, I'll just send you the change of price, things like that. But what happened is on the decoder must put it back together. It becomes stateful. So what was the price I need to apply the delta to? So it actually requires a lot of CPU cycles to do that. So SPE, when we designed SPE, it had a different problem. Now by this time, the data communications was not quite so expensive anymore, so that was less of an issue. However, we want to optimize latency. So SPE is designed to minimize latency. And so we have small enough messages, but we're not spending extra CPU cycles, compressing and decompressing. But the standard is still out there, and I think there's still some users of it.
Okay. The second question that I saw is, you mentioned most of the execution reports are optional fields.
Yeah.
If these optional fields are not assigned, we're not allowed, and we're not assigning any values to that, will that take up the number of bytes transmitted online after SPE encoding?
Yeah, so we take a different approach with the design of messages. So as you say, execution report, if you look at Fiximate, it's the length of execution report is, the table is pages long. You have to keep scrolling to see all the fields. So the reason for that is it's the universe of all possible values on all exchanges, all market types, all asset classes, and so forth. So when you design an SPE message, you don't want to take that shotgun approach. You want to very narrowly tailor your message design. Most of the time, you want to have it so your message template has only the required fields, ideally, for a particular use case. So I'm not going to design a execution report for every possible asset class and exchange. I'm going to design a template that covers one event, like partial fill, let's say, for one asset class for one exchange. It's not general purpose for everything. It's a very specifically tailored use case. And so if you design your messages that way, you could get very small messages with mostly or entirely required fields instead of all these optional fields. We still, of course, do support optional fields, but they do not save you any space.
Okay, a few more questions here. One question here is, compare with fix or the tag value, what is the performance improvement gained by SPE?
Yeah, so we even had improvement over Fast, by the way. It was fast. It's faster than Fast. So compared to tag value, let's say encoding or decoding, I think you did pretty well in tag value to encode or decode a message in about a millisecond. Now there's some tricks I'm aware of, like you could, if you're trading and you can prepare a message in advance and just poke a price into the message at the last minute and send it. So there are some tricks, but as compared to fully encoding or decoding messages, it's orders of magnitude faster than or lower latency than tag value. According to one implementer of SPE, a message of reasonable complexity can be encoded or decoded in about 30 nanoseconds, as opposed to millisecond range. So that's just vast difference in latency. And according to one benchmark, I don't know if this was still valid, it was done a few years ago, they claimed it was 20 to 50 times faster than Google protocol buffers even, which is also binary encoding.
Okay, there are two questions around the the extension. I'll try to see whether I can translate it correctly. The first one is, can you sort of introduce a bit more about the SPE's extension mechanism, such as adding field, group, or data after that? Whether the messagings will need to be upgraded on both ends. So that's one question. And the other question is whether there is in terms of the simple open framework or SPE, whether you have already reserved SPE after encoding, whether you will have other features like compression and other tags. Are there any extension plan in the future?
Well, to take the last question first, there's no standard around SPE for compression. In fact, it was kind of a motivation not to do compression, but I can't say that you couldn't do compression, but we just haven't found it necessary. But we're always open to ideas on that. To take the previous question about the extension mechanism, I kind of skipped over several slides there because they went into a lot of fine detail that I didn't think we had time for. But the gist of the extension mechanism is you can't always get all your encoders, all your decoders synchronized on one version of your message. So you start publishing a new version while there's still some older decoders running. And this is certainly the true with customers where you don't have direct control over what they do. But even within an organization, you may have so many systems that they're hard to all update simultaneously. So the whole point of it was I could start encoding a new version of the message template, and the old decoder, let's say it's one version behind, it will still be able to decode the part of the message it knows from the previous version, but it will not be able to decode the new added fields. So that's the gist of it. And new fields are added at the end of a message block. So one thing that helps with that is the message. There's a tiny SPE header on a message that tells the size of the block that follows. So I know the whole space that is transmitted to me. I know how to decode a portion of it, but not the whole thing. I know there's some new material out there that I don't know how to decode, but since I know the message size, I know how to skip over it and get on to the next block. So that's the short description of how the extension mechanism works. There's a lot of constraints on when it works and when it doesn't work. And if you need to make more radical changes to a message, then the best policy is just to create a new template for it.
Okay, Carl.
Sammy, I got some questions here. So
okay.
So apologies, I don't have ability to read chat, but Barbara sent me some. Okay, I'll go over some of them now. So one question for you, Dong, is you mentioned in the execution report where you allow a certain field not to be assigned a value. So under SPE, after that, they will still occupy some bytes, some bit on the network. Is that right?
Right. So if there's no value, we put the special null indicator in that space. It takes exactly the same space as if you had put, let's say it's an integer field. It takes the same integers space that the integer does. There's no saving in space for a null value, unlike the tag value. So there is that trade-off, but it gives you that determinism. Yeah, it's always in the same position.
刚刚那个问题是关于那个execution report 里面如果有 如果有一个值是没有赋值的，会不会还是占用网上的带宽数据带宽？那答案是还是会占用带宽的，因为这是固定的长度的那个数据结构。
Okay.
And 其实我
Go ahead.
也其实我自己有一个问题，我可以问一下吗？
可以。
So 我的问题是，那从客户的角度考虑，那比如说一个 buy side 通常会跟几个 sell side 有联系。如果sell side 其中有一些 sell side 可以 support SBE， 有一些没有。那而且每个 sell side 的那个 broker 的 SBE 的 protocol 也会不太一样，我相信，因为他们有自己的一些内部的 coding 啊，比如尤其是 repeating group 这种类似的数据结构。那这种情况下，从 buy side 的买方的角度来考虑的话，怎么样的 setup 是最合适的？有什么样现在是已经有的toolkit 是可以让客户比较方便的和不同的对接端、不同的数据端进行结构，甚至还可能会考虑到一些 backward compatibility 的 issue， 比如说有一些 broker 还在 traditional fix， 然后有一些 broker 可以 support SBE， 那这种情况下有什么好的解决方案吗？现在 So Don, the question is, given the complex broker-dealer and buy-side connection network we're in today, it's very likely we're going to face backward compatibility and the mingle mesh with the different brokers on different versions of SBE, and some on SBE, some still on traditional fix. So is there a plan or existing toolkit that allows client to have an easy setup? Otherwise, I can imagine this to be a very difficult situation for them.
Yeah. So that, by the way, was one of the motivations for the simple open framing header. There's only two fields in it. One is what is the encoding that follows, and let's say you're in transition from tag value encoding to SBE, and you have some work that's done in both encodings. And let's say you have a drop copy system, for example, that has given you copies of executions. That some are done in tag value encoding, some are done in SBE. So you could have one stream of data that even mixes the encodings. So that's one possibility. So in terms of transitioning from tag value to SBE, one thing that helps with SBE is that the message schema is machine readable. So what is commonly done with it is you generate encoders and decoders. You generate the code for that from the schema. So that's very different from what has typically happened in the past with fixed classic or fixed traditional, we'll call it, where the exchange or the broker gives you basically a PDF document that says, well, here's my message layout, and here's in humanly readable text, description of it, and you're just giving it to you in that form and not machine readable. So actually, it should be easier to convert to SBE. Also, it's not so dependent on having what we called a fix engine in the past, which did that whole protocol. So it's very easy to generate the message encoders and decoders in various programming languages just from that XML file. So you may have many different message schemas to deal with as a firm, but you could automate a lot of the work it takes to know how to interpret the messages.
Thank you very much.
Okay. There's a question about fixed component tag. I think I will get Carl to help to translate later. If you can see that, do you see that question, Carl? It's about the fixed. There is a question about fixed component tag and the conversion. I mean, it's too complicated for me to translate. So if you can take a look at that question, I think it's a very last question that you have. If you can take a look at there and translate. But I think in the interest of time, maybe I'll ask Don one question first. Is what I think that some audience want to know the application of SPE in North America, and in what kind of market coverage and what business is mainly using.
Yeah, so North America, in terms of exchanges, you know, the original one to use it was CME, and you know, I was at CME at the time that we were developing SPE, in fact, and created it first for market data usage. Prior to that, they were using Fast and encountered some issues with it that were not functional issues. They were organizational type issues. So we had to change to a different encoding. And so I helped to develop SPE. And so in terms of futures and options, you know, CME is a major exchange in North America. But worldwide, you know, I could say there are several others, you know, like B3 exchange in Brazil. One of the first to use it was Moscow Derivatives Exchange. I think Euronext is using SPE. But in addition to the exchanges, you know, many, you know, brokerage firms are using SPE, you know, with their partners or with their clients, and also for internal messaging as well.
Thank you, Carl.
好的，give me one sec 这个问题，我先重复一下这个问题，是关于 fixed component 标签的部分。Okay, so Don, I'll try my best to translate this one. It's a bit difficult for me as well. So the question is, in fixed, there's a component tag part, and how do you convert that into SPE? So the question is saying SPE has the component redefined into composite, but it's only but it can only be converted when it's a fixed length. So what the question asker said, he's saying that he thinks the current solution for that is to use the repeating group of 1 in SPE.
Yes.
So do you have another way which is more efficient?
I don't. In fact, that's a solution that I have recommended to people in the past. And one benefit of that solution is you could take advantage of the extension mechanism. So if you have a component as a repeating group of size 1, and by the way, you could specify in your message schema in the metadata that I only want it to have 1 element. It could be extended in the future through the extension mechanism. You could add fields to it later and not disturb the rest of the message.
Thank you, Don. Any more questions from the audience or you, Carl?
I'm all good, thank you.
Okay, I think these questions, one more question is submitted prior to the event is, you know, what are the rights and the advantage of joining as a fixed member? I'm not sure whether that is a question for Don or maybe Ed or Lisa can sort of take up that question.
I think Ed should take up that question about membership benefits. Yeah.
Okay, Edward.
Yeah, hi there. Can you hear me okay?
Yep, perfectly.
Okay, perfect. Yeah, I mean, in terms of the benefits, particularly in Asia Pac, we get a lot of feedback from our members, and when we ask about you know, what they're getting out of membership of the fixed trading community. In Asia Pac in particular, there's a lot of work that goes through the committees and the working groups. And I guess the major benefit we see in Asia is the ability for industry peers to work with each other, to work with their clients, to work with different sort of constituents of the industry, for example, exchanges, buy side, sell side, technology firms, on coming up with solutions. Now, a lot of those solutions, of course, will involve the use of the fixed protocol, and where the fixed protocol needs to grow then we can actually do that. We can pull the trigger, if you like, on making things happen and creating solutions. And they are standard solutions for the industry. So that is, I would suggest that's the #1 benefit to our members in Asia. And of course, that applies to the China Working Group members as well. The other side is, I guess, hand in hand with that, is just the ability to network these problems. And really that sort of comes back to identifying challenges across different areas of the market. So for example, at the moment, we're doing a lot of work around ETF workflows and looking at standardizing those approaches, and potentially using the fixed standard as well. The benefit to the industry for those using ETFs is huge, because again, particularly in Asia, with many jurisdictions, you have many different approaches. So within the community, we bring together market makers, issuers, the APs, basically that community, all working together to a common aim. There are, of course, other benefits. For example, we do a whole load of conferences around the region, which in many markets, again, brings the industry together, highlights best practice, and indeed within the fix community, we can also, for example, create recommended practices that the industry can get behind. So yeah, I would say that the major focus for us is on the ability to network and actually pull teams together to create industry outcomes. I don't know if that will, if Lisa, you've got anything to add, or indeed Sammy on the conferences.
Yeah, actually, Ed, yeah, I think the other thing to add to what you just said is, by becoming a member, you're also tapping into, the knowledge and the brain trust, if you will, at a global level. You have that ability, because at least in my involvement with Fix was for 20 years. A lot of the problems are actually very similar globally, even though people use this different terminology to describe what they're facing. But in the end, there are a lot of parallels and a lot of similarities that we can leverage solutions that may be in place or tweak solutions that are in place to meet the local needs.
Okay. I think that sum up everything. Of course, I mentioned conferences and webinar or meetings like today. I think there are quite a lot of information that can be shared and know-how as well. Okay, there one question from me and one question from the audience. I will just read out both to you, Don. First question is, I think you mentioned Fix Orchestra earlier on, I think as a plug. Is there any relationship with Orchestra and SPE? That's number one. And number two, the question is out of brand metadata. So every time when the SPE message is sent out, whether it will send out after each SPE message with the out of brand metadata, just like the header?
No, by out of band metadata, what I mean is the message schema, which is an XML file, is not disseminated in the same communication channel as the data to send. Now, it could be published on a website, or distributed just as you distribute documents, or for download. We do have one possible relationship with Orchestra is Orchestra has a couple of schemas. One of them we call interfaces, and it describes your service offerings. And it can actually tell you such things as a message schema or other machine readable files that you might need to run some service. So the interfaces file it would be kind of the root of everything, and it might say your message encoding is SPE version 1.0, and here's where to get the message schema. And it might be available through, again, through a website or you know, a download of some sort. However, that's communicated.
Okay.
But the message schema is not sent in line with the data. It's sent through a different channel.
Okay, thanks. Any last word before we let you go, Don?
Yeah. So you know, maybe down the road we'll have another session on orchestra.
Oh, okay, great. I think thank you, Don, and you know, for the presentation and also staying up late for us. Thank you very much once again from the China Working Group.
Okay, my pleasure.